This problem asks you to use 6 subintervals to estimate, being the key language here, the area between the curve and the x-axis for this given equation on that specific x interval there from 1 to 3. They want you to do it as a left-hand sum, a right-hand sum, a midpoint sum, an upper sum, and a lower sum. So basically, they want you to run through all of the different Riemann sums options that you can see. I've covered the left-hand sum, the right-hand sum, and the midpoint sum in their own videos. This one, I'm going to cover both the upper and the lower sum at the same time because so much of the work is identical. It's just a decision point that varies ever so slightly between the two of them. So no matter which version of this I get, I start off the same way. I am going to label out my x intervals. So I'm going to draw myself a number line. I'm going to put 1 on this side, and I'm going to put 3 on this side. Now I need to break this number line up into its subintervals. I need to find what we refer to as our delta x, our change in x. The formula for finding your delta x is always going to be max minus min divided by the number of subintervals they want. So in this situation, our max of our interval was 3, our min on our interval was 1, and the number of subintervals they wanted was 6. So out of there, we get 2 over 6, which is going to get us 1/3. So our delta x is 1/3. We use that delta x to mark off the remaining tick marks on this interval up above here. So starting at the left-hand side at 1, I add 1/3 to that. So 1/3 plus 1 gets us 4/3. I add 1 to that, and I get 5/3. I add 1 to that, I get 6/3. 6/3 is better known as 2. I add 1 to that and I get 7/3. I add 1 to that and I get 8/3. And then I add 1 to that, I get 9/3, which is also better known as 3. From here, I come through and I label out my subintervals. It reminds me what I'm trying to calculate, and it also A4, A5, and then if I did everything right, I should end at A6 because that's the number of subintervals they wanted from me. From here, this is just what I refer to as the assembly line process. So as we go through this now, it's kind of the same steps all the way through. So we go A1 equals, A2 equals, A3 equals, A4 equals, A5 equals, and then A6 equals. And like I said, I'm going to do this for both sums at the same time. So we'll do this one as the upper sum. And like I said, you can really just kind of lay these things out right next to each other. So then over here, I'm going to do A1 equals, A2 equals, A3 equals, A4 equals, A5 equals, A6 equals. And so on that chart there, on that table, I'm going to do the lower sum. Both of these formulas are coming from the area of a rectangle formula. So the area of a rectangle is equal to base times height. The base on all of our rectangles here is going to be the same. The base is this distance across right here. That was our delta x. That's that 1/3 gap that we used to pop in all of our different tick marks. So the base on all of these is going to be delta x, delta x, delta x. Like I said, this is just an assembly line process you kind of go through. The more of these you do, the more you can kind of find your own places to skip a step here and there as long as you're not skipping too much. But for now, as you're learning it, it's best to kind of go through the full process. Now, here's where the difference is going to come. The height in these is going to come from our function value, our y value at these given points. So we want to do f of, f of, f of, f of, f of, and then f of, and then equals, equals, equals on all of these. And so then guess what we do on this side? It's going to be another f of, because the only thing that changes is what we're actually going to plug into those points. So what we plug into these equations is going to be the piece that changes. So on the left-hand side here, we are going to be doing an upper sum. When we talk about upper sums and lower sums, the upper sum is telling us that we want the largest y value out of our options. So you're going to have two options to choose from. You'll have a left-hand side and a right-hand side on every single interval. And whichever side has the largest y value, that's going to be what gives us our upper estimate, our over estimate. And then on the other side of this, we've got our lower sum. And when we talk about the lower sum, what that means is we want to choose the smallest y value from each little subinterval. And so that lies the difference between the two problems. And so unfortunately for us, what that means in these situations is we actually need to know the y value, the function value, at every single one of these evaluation points. Because the only way you can pick the largest and the smallest y value is if you know what the largest and the smallest y value is. So we start here at 1. So I go f of 1. I'm plugging all of these back into the original equation to find out what the y value is that goes with it. So I plug in 1, and that's going to get me out a y value of 1. I'm doing the same thing here. I plug in 4/3, and I'm going to get out of there 52 over 27. I'm going to plug in 5/3. We just have to know what all of these y values are. I plug in 5/3 and I get out 59 over 27. I plug in 2 and I get out of there, what is that going to be, 2. I plug in 7/3 and I'm going to get out, so f of 7/3 gets me, I'll plug that in, you get 43 over 27. I plug in f of 8/3 and I get out of there 32 over 27. And then I plug in 3, and when I plug in 3, I get out 1. So what we are looking at right now is we are looking at the answers on all of these. We are looking at the y values. So we are going to come through first, and we are going to fill out our upper sum. So looking at A1 right now, you've got two options. You've got 1 or you've got 52 over 27. You want to choose the larger one. 52 over 27 is the larger, so we're plugging in 4/3. Going to A2 now, you are comparing between the left side, which is 52 over 27, and the right side, which is 59 over 27. We want the larger of the two, so we are going to choose 5/3 because that gets us 59 over 27. Working into A3 again, we compare 59 over 27 to 2. And in that situation, 59 over 27 is bigger than 2. So again, you would choose the 5/3 side because there's no left and right here. It's the largest y value is what we're going for on every interval. So you can sometimes double up on the answer because it is the largest value for both sides. So then I look at A4, same game. I'm looking between 2 and 43 over 27. And so 2 gets me 2, and that's bigger than 43 over 27. So I choose that one. On A5, I'm looking at 43 over 27 versus 32 over 27. That means 43 over 27 is the larger. And then on that last interval, I'm looking at 32 over 27 or 1. 32 over 27 wins, so I'm plugging in 8/3. So those are my evaluations for the for the upper. And now we come back through that same list of values, and this time we are looking for the lower estimates. So we want the smallest y value on each one. So we start back at A1. And we're choosing between the same two values, but this time we want the smaller one. So we're looking between 1 and 53 over 27. 1 is smaller, so we would plug in 1. Doing the same thing on A2, you'd be looking at 52 over 27 versus 59 over 27. You want the smaller one, which is 52 over 27, so you'd plug in 4/3. Go to A3, your choices are 59 over 27 or 2. You want the smaller value, which is 2, so you plug 2 in. That was our evaluation point. Then we go on to the next one. We get 7/3, plugging in 7/3 versus 2. And so our option in that situation is going to be the 7/3 because that gives us 43 over 27. Then on A5, we're going to be comparing 43 over 27 to 32 over 27. We want the smaller one, so that's going to be at 8/3. And then at the very last one, we're comparing 32 over 27 to 1. The smaller value is 1, so we would plug in 3. So at this point, it's just a bunch of calculations. Really, all this is a battle of wills. Like it's going to take you a while, but it's not a hard process. So I come back in and I say, okay, delta x is 1/3, 1/3, 1/3. Again, this is just our assembly line process, and that works over here. All these delta x's are 1/3, 1/3, 1/3, 1/3. And now we come back in and plug in those actual y values. So f of 4/3, reading off of our table up above there, we get 52 over 27. And we're just working our way down. 5/3 got us 59 over 27. 5/3 again gets us 59 over 27. 2 got us 2. 7/3 gets us 43 over 27, just reading those y values off of our data up above. And then plugging in 8/3 gets us 32 over 27. And then those sums right there, we'll multiply those out, but we might as well kind of keep in the same thought process and do the lower sums. Plug in all of our evaluation points and get those y values. So we plugged in 1 and we get out the y value of 1. We plugged in 4/3 and we get out the y value of 52 over 27. Plugged in 2 and we got out 2. Plugged in 7/3 and we get out 43 over 27. Plug in 8/3, you get 32 over 27, and then plugging in 3 gets us 1. And so now, again, we just come back through and we multiply all these together. So out of here, we're going to end up getting 1/3 times 52 over 27 is going to get us 52 over 81. 1/3 times 59 over 27 gets us 59 over 81. It's the same thing here, another 59 over 81. 2 times 1/3 gets you 2/3. Then we end up with 43 over 81 and 32 over 81. Those are all of the areas of our little subsections there. And now we do the same thing for the lower side, and we just multiply these out. So 1/3 is going to get us 1/3. Then we're going to get 52 over 81. 2 times 1/3 gets us 2/3. Then we're going to get 43 over 81. Then we're going to get 32 over 81. And then we're going to end up with 1/3 at the end here. So to get our final estimate, our upper estimate, our overestimate on this thing, you would go ahead and just add up all of those values right there. So you're just going to add them. Again, it's not very hard, it's just a long process. And when you do that, you're going to get out of there 299 over 81. That is your upper sum. That is your overestimate for what this is going to be, because you grab the largest y value every time. And then you come back through and you do the same thing over here. You're just going to add these up. And that's going to get us our lower estimate, which is going to be an underestimate of what the actual area between the curve and the x-axis is. And putting all those together, we end up with 235 over 81. And so that value there, that is your lower estimate. That is an underestimate for what the actual area between the curve and the x-axis are. So upper sums and lower sums are a bit more of a pain because you need to know what the y value is at each side of your interval so that you can choose at each point which one is the larger or the smaller y value, depending upon whether you're looking for an upper sum, largest y value, or a lower sum, smallest y value always. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.